Hi everyone, please get this warm up from Canvas and begin working on it. This is a review of Unit 4, and if you need an example of when we did this, it was how many children are in your family. So you could click Unit 4, click how many children are in your family in that overview table, and then you can see an example of this. But if you pause here and try it out, I will go over it in a couple of minutes. Okay, so like I said, this is a review, and we're starting to review for your AP exam, so we're trying to trickle in some stuff here. And also, this is in our lesson later, so it's important to just remember how to do some things from the past. Everything builds in this class. So a couple things I'm going to make notes of just for your reference for FRQs for the AP exam, and then in general is for this first one, we need to always show work. So even though it might seem silly, you need to show how you got your answer of 0.08. Same thing here as well. And then for C, histogram, make sure you label the axes. That's very important. And then for letter D, the formula that we're using is on your formula sheet, E of x equals mu sub x, and it equals the sum of each x, so we use the little I for each one, times the probability for that x. So here's our formula sheet, and it's right in the front, right there. I got my E of x and the mu of x backwards, but it's the same idea. So you need to show the first, second, and last, just like I showed you on the video for the last class with the goodness of fit test. Whenever you show your work for a formula that involves adding up a lot of things, you have to do the first, the second, and the last. And then this interpretation is something that we learned back in Unit 4. So you can look at that lesson, like I said. And again, we will be using that formula today and the idea of expected values as a reminder that it does stay a decimal. So here's an example of when we kept it a decimal back then too. All right, so for our activity today, what we're going to be practicing is just more goodness of fit test, but we want to do the whole entire 4-step process. So here's an example, and then I also want to show you how to use rubrics to score yourself. So here's an example of an FRQ from a different year, and we have a bunch of stuff for you to read. The main thing here is that they have this table. This is really a one-way table. These are what we would call our P sub I, and then these are the observed values. So this is our sample size, 117, and then this is, I would just call this P1, P2, P3, and P4. So this question is asking us, if you look on the next page, it asks, conduct an appropriate statistical test to determine if the data are consistent with the expectation that the number of moose observed in the habitat is proportional to the amount of acreage. So the way that we would set that up is, it's a one-way table. We have a list of proportions. We're doing it just like we did last lesson. And so these are going to be your null hypothesis, where you list all of them out. Then your alternative hypothesis is what we learned last class, so you can refer to your notes for that. Then don't forget to define the parameter, the proportion of moose in each habitat type, etc., and do the 4 steps of pass. So the next page has pass kind of filled in, and you're able to do that there. So I'm going to have you pause here, complete part A and B on the next page, doing the 4-step process, and then we'll unpause to go over the answers and show you how to use a rubric to grade yourself. Okay, So here are my answers. I'll just zoom out a little to show you everything. Remember, your null had listing out each of the P's from the table. At least one or two is different for your alternative, and you need to define the P. Don't mention anything about the word observed in your null, because it's not about the observed, really, it's about all moose, and so we don't want to just talk about these 117 moose. And then this is a chi-square goodness of fit test because it was a one-way table. Now this problem said assume the conditions for inference are met, right there, right here, sorry. And so I was able to just write that, but I do want you to make sure that with this large count, so you have to draw and label your expected counts. And so I want to make sure you knew where to get those. So in this case, we're going to do our sample size times, we'll just label them. I like to label them. So we have habitat 1, 2, 3, and 4. And we have 117 times 0.34, 117 times 0.101, 117 times 0.104, and 117 times 0.455. And so what you can do is, remember, in your calculator, we go to stat enter. We have all this stuff in our list already. We hit second plus 4 enter will clear them all for us. And then we will type in these values. So we have our observed in our L1. Remember, we wrote this down last class, so if you had trouble with this, make sure you're doing it now to follow along. And then in our L2, we have our expected. So I could just type 117 times 0.34. Like that, and it will do it for me. And then I could type 117 times 0.101. I can do 117 times 0.104 and 117 times 0.455. So it's all, oops, that wasn't 117. 117 times 0.455. Okay, so there they all are. And then remember, in our L3, we can go over here. We can do parentheses, observed in L1, minus predicted in L2, squared over predicted. And we get all those. We go to the home screen. We hit second stat math 5, sum L3 up. We get our chi-squared value, and we do second vars chi-square CDF. It was number 8, actually. I don't need to go backwards. And then I could put the answer, or I could type in 43.689, whichever one. And the DF is n minus 1. So 4 minus 1 is 3. Okay, so that's 1.76 times 10 to the negative 9. So that is where I got all that stuff from. So remember that we have these 4 values. We can write the expected counts down. I want to write them down from my list. Stat enter, 39.78, 11.817. Let's see the other two. 12.168 and 53.2. Let's see, let me find that. 235. So make sure you always draw and label your expected counts. I need to draw, but that's key. Then we have our stuff, all that. And then because our p-value is less and the component was the largest for habitat 3, which we can see in the L3 is really the best place to see that. It's the largest, and then you can see that 30 were observed, but only 12 were expected. So that's why they seem to prefer habitat 3. Now let's look at this in the AP rubric. So there's a lot of options for how you can score this, but let me just show you a couple things. So this was 2008 question 5, and this will be linked in Canvas as well. The primary goal of this question were to, 1, assess the ability to state the hypotheses, identify and compute appropriate test statistic, make a conclusion, and compare the 2 sets. And so these are 4 different points. Each thing right here is a point. And so this, where all FRQs are worth 4 points, and you'll see in the intent part of the rubric what the breakdown is. And so here is the solution from College Board. This is always very thorough. Read to see the best answer, and then skip to scoring guidelines to grade yourself. You don't need to use the solution to grade yourself. Okay, they're going to do a really thorough job, and you don't have to do all of that, but here's all the options. Then we have our test name. Kites are going to fit test. They put the formula there sometimes. They said the conditions were met. Here is the correct mechanics, including the value of the test statistic, the DF, and the p-value. So if you follow with how I tell you to do it, then you will see that you'll get all the points every time for this step. And then step 4 was a correct conclusion. And then we had part B. So we had the 4-step process right there, and then part B was its own point. And so here, I'll let you look at that for a second. And so here's where they tell you how to do the scoring. So they tell you that in the section 1, we had part A, step 1, section 2 is part A, steps 2 and 3. So that would be the P part of pass. Steps 2 and 3 are the A and the S part of pass, and then section 3 was step 4, which is the last part. And so we want to use all that, and then part B was its own thing. So they'll typically try to take the 4-step process of pass and then break it down into a couple of points. And then here is where they tell you how to grade yourself. So we really want, see how it says given in context. That means that we define the P, or don't use symbols. And then we want to have our conditions, which in this case they were already done. We have the DS and the statistical work, and then the conclusion and the context. Remember, we always want to compare the p-value to the alpha, et cetera, et cetera, et cetera. So this one, just you can read through it and look at it yourself to make sure you got all the steps. What I'm showing you here is how I taught you to do it, which will cover all of the points. So if you do it how we say, then you'll always get all credit on the inference questions on your exam. All right, so here's a couple little notes about that grading process. So once you've looked through it, hopefully you'll see some of these letters that they mentioned. So E stands for essentially correct, and they'll give you the criteria on the rubric for what's considered essentially correct. P is partially correct, and then I is incorrect. And typically they take each section that they have identified and they'll award you an E, a P, or an I for that section. And then they'll combine them to create points in the end. And then you'll never get a half a point. Sometimes the P's are worth half and the E's are worth 1. And then when they add them up, you get 2.5 points or something like that. They'll never give you 2.5. They'll give you a 2 or a 3. And so they decide based on the holistic answer you've given, and they'll either round up or round down. So just make sure that you are very thorough yourself and you give yourself as many chances to get rounded up as possible. That's why we have you draw the pictures there. That makes it seem like you know what you're doing more, and show all your work with filling in the formulas. If you have trouble with coming up with an answer to one part, then you just need to make a number up and then use it in the other parts, because you don't want to miss later sections just because you couldn't do the first part. Just make sure the number that you make up makes sense. So if you're making up a probability or a proportion, make sure you use a decimal between 0 and 1 so that it actually makes sense, because they'll take off points twice if what you make up makes no sense. So just be careful about that. All right. Now, this next check your understanding is another FRQ from another year. So I'm going to give it a try. What I have is on one page is the FRQ itself, and then on the next page is, kind of a broken down table for you to fill in for your solution, and then you'll use the rubric to grade yourself. So the rubric is linked in Canvas. We're going to call it Spinner Solutions. Don't look at it until after you've tried to check your understanding, and then once you look, grade yourself. So A and B are review of Unit 4. That's why we did that warm-up earlier, just to review a little bit of probability. And then C is a chi-squared test, goodness of fit test. So you'll do the 4-step process on C. So I'm going to give you a pause here. I want you to try to use the rubric to grade yourself after you finish. And then if you need any help or want me to look at the rubric, discuss the rubric, you can unpause the video and I'll go through some of it as well. Okay, so here is my solution on here. And so remember, you have to show your work to get credit for part A and part B. And then part C is the 4-step process. So we have P, A, S, S. And so I kind of labeled them over here, PA and SS. To use the rubric to grade it, then we go to Spinners. I'm going to go here. And so remember, you look at the answer key for like the best possible answer, and they sometimes give you multiple ways to do it there. So if you did it a different way, you can kind of see, maybe they showed a different way there for you to look at. And so hopefully you look through that. Then we go to the scoring. So in this case, this is an old one, so they didn't use essentially correct, partially correct, etc. But we'll say E and P, E and P. And so they have correct answer 0.4219. And see how you get a P if you didn't show any work. So make sure you showed work. So for me, I did great job showing work. I'll give myself an E. The second one, we have 800 is there. And then P if you made a mistake somewhere. And then you have some computational errors. And then if you give 800 but with no work, etc. The formula is given but no calculations are actually done, etc. So again, I showed my work, got the answer, that's an E. And then the last part, we have correct hypothesis, correct test name, and the conditions, correct mechanics, and the statement of reject or fail to reject, etc. So we did all of that. Oops. And I got an E for those two and an E for those two. So hopefully that makes sense, and we'll keep working with rubrics as we get closer to the AP exam. You guys have some 4-step process problems to try in saplings, so go get to those, and next class we'll learn another type of chi-squared test before we have a quiz. Not next class, the quiz is 2 classes from now, 3 classes from now.